Okay, lesson 3, we're now going to be looking at rational functions. So we spent some time for the last 2 lessons on radicals. Now we're going to be looking at... Now, some of this is going to be entirely review, and a little bit is going to be new. Now, whenever you have rational functions, the thing that actually decides if it's going to be irrational is if there is ever an x in the bottom, okay? And that's going to give some different types of graphs. And one thing, too, that you need to know is if you have a TI 84 plus, it does not graph the asymptotes. Or TI 84, the 83 plus does graph the asymptotes, right? So even when we were pulling up graphs, people were like, mine's not doing it, mine's not doing it. Well, and in some ways, each has its advantage, but you guys will learn to be able to find those quite well. Now, asymptotes, like the vertical ones, are numbers that are not allowed. Now, just in the first example here, what is not allowed here? 1. How about here? Plus or minus 3, right? Because negative 3 squared. Okay, how about here? Negative 2. Okay, so those are non-permissibles. Meaning if you put them in there, you get an answer of 0. You cannot divide by 0, therefore it doesn't exist. Okay? So we're going to be just looking at discontinuities. There's the infinite discontinuity, that's what we call a vertical asymptote, or the point of discontinuity, which is the hole in the graph. Okay? Now we have dealt with both of these before. I'm going to deal more with the point of discontinuity more on Monday's class. Today we're just going to be talking about vertical asymptotes, and this is going to make you very happy. I need you to turn to page 460. And we're going to talk now about horizontal asymptotes, okay? Now, horizontal asymptotes are something that I know you've seen many times, but we haven't mathematically dealt with them. So we're going to start dealing with them today. Now, again, if you're in taking calculus, this should be review. And then, of course, you're even going to go farther into depth. So we're just going to touch on this stuff because this is pre-calculus. So a few more things are thrown in to help with that. So vertical asymptotes, you know, these are your non-permissibles. Now remember, there are no non-permissibles usually in the numerator that will give asymptotes. Okay? So the new one we're talking about are horizontal asymptotes. Now horizontal asymptotes, I think they describe pretty well what they are, but they're going this way now. Okay? So horizontal asymptotes would be a horizontal imaginary line instead of the vertical ones. Okay? Now, there are 3 kinds of rules to identify horizontal asymptotes. So we're going to get right to the 3 types right now so you can see the difference between them. The first one is if the degree of n of x, now every time, so we're over here, every time n of x, oh, what are you doing? N of x, right here, that stands for the numerator, okay? It says whenever the degree of the numerator is less than the degree of the denominator, okay? It will have the line y equals 0 as the horizontal asymptote. So an example is 3 over x. Now, I like to think of it as the denominator has a higher degree than the numerator, but you could say the numerator has less than, it doesn't matter. Other examples would be even 3 over x squared, as long as, or, 2x squared over 3x to the 4. Okay? Do you see how there's always a bigger degree on the bottom than on the top? Okay, and then what am I talking about when I say that it will have a horizontal asymptote with y equals 0? Y equals 0 is a synonym for the x-axis, and x equals 0 is a synonym for the y-axis. So this is what we talk about when we say it will have an asymptote at y equals 0. Now the second scenario, there's only 3 scenarios. The second is, what if the degree of n of x is equal to the degree of the denominator? It will be a horizontal asymptote at where the a is a leading coefficient and b is a leading coefficient. Okay? So what you do, you first of all see these are both to the same degree. So that means I will have a horizontal asymptote at 2 over 1. Okay? So this would have a horizontal asymptote at y equals 2 over 1. Okay? So that would look something like this, right? It would have a horizontal asymptote about here, that being 2. Okay? Now again, examples are the nice way to kind of understand this. What if I had y equals, 3, x squared plus 5 over 2x squared minus 3. It will be 3 over 2. Good. It will be, those other numbers, I'm not worried about it. I take these two, they're both the same, so it will be 3 over 2 will be the horizontal asymptote, okay? Well, I'll say y equals 3 over 2 is the horizontal asymptote. So it's actually a pretty simple concept once you see it. Now, what if the degree is greater than the degree in the denominator? Okay, so here's your example. See how it's bigger there? Now, it says it has no horizontal asymptote, and that's a little bit misleading. It does have an asymptote. It would have an oblique asymptote. What does oblique mean? So it'll be slanted. Now, does anybody know how to find the equation of that slant? Actually, I shouldn't have drawn that as a, that should be a, how do you find the equation of that? You take this, divide it by this, and you'll get the equation of that line. It's that simple. So if you took this, divided by this, you might get, x, do I do it? Yeah, I do it. You get x plus 2. So x plus 2, I remember x plus 2, okay, that has a slope of 1 and a y-intercept of 2. You should remember that. Y equals mx plus b. So that's how you can just divide them. Now, you do not have to find oblique asymptotes for 30-1. It's y equals 0 in this situation, or y equals negative 5/8 in this situation, or no horizontal asymptote. See, this is not a horizontal asymptote. So 0, other, no. These are your 3 scenarios. When you have a bigger degree on the bottom than the top, it is 0. When you have the same degrees, it is the coefficients divided by each other. When the, I shouldn't say same, yes, when you have this degree bigger than this, it's oblique or no horizontal. Okay? So we're just going to do this one example together, and then you can do your homework, which hopefully will not be homework. Now we're going to do this. Now there's something really, really valuable to learn here. Okay? So we're all going to be doing this together. Now the first thing you must always do before you do these questions is you need to factor. The reason why we should always factor is that way we can find the non-permissibles in the bottom. We can also see if something cancels, because if something cancels, that is going to be a point of discontinuity. So, the top, I'm looking for two things that add to give me 1 and multiply to give me negative 6. What would they be? No. Yeah, sorry, 3 and negative 2. 3 and negative 2. Good. So this would factor to be x plus 3, x minus 2. Okay, now the other one, I'm looking for two things that add to give me negative 1 and multiply to give me negative 6. What are they? So negative 3 and 2. So it is 2x squared minus 3x plus 2x minus 3. Put a set of brackets here. I can take out a... Can I take out just an x, leaving me with 2x minus 3. Here I can take out a 1, leaving me with 2x minus 3. So this factors to 2x minus 3 times x plus 1. Okay? So now we're going to come all the way over here, and we're going to rewrite this as x plus 3, x minus 2, all over 2x minus 3, x plus 1. Okay, now nothing cancels, and that's important to check. Tomorrow, next day, Monday, sorry, everything's going to cancel because we're going to do point of discontinuities. Now, let's first do vertical asymptotes. So, what are the vertical asymptotes? X cannot equal what? Give them to me. 3 over 2 and negative 1. So that's, if I was talking domain, that's what x is not allowed to be. But it asked me the equations of the asymptotes. So the equations of the vertical asymptote would be x equals 3 over 2 and x equals negative 1. Those are the equations of the vertical asymptote. So when I'm saying, what are you not allowed to use? That's a very different question than what is the equation. Because what am I not allowed to use? I use that as my equation, okay? Now, horizontal asymptotes. All you have to do is look right here. So it is 1x squared over 2x squared, right? So we just look at this. So the horizontal asymptote is at 1/2. Or, sorry, y equals 1/2. Now, what is more important now is to see what is going on in the graph. So I'd like everybody please to get out their graphing calculator and get the equation in. So whenever you do this, do the original equation, not your factored one, so you aren't graphing a mistake you made. So you're putting x squared plus x minus 6 up top in brackets, divided by 2x squared minus x minus 3. Okay, everyone got it in? Now hit zoom 6. Okay, and then you're going to see right away, anybody that's got an 84, you will not have this asymptote in here or this asymptote. And you can see why they got rid of it, because it's not even a good asymptote, right? It looks more like someone that is on their last breath, right? So it has taken this out, and then you just have to know. Now, if anyone could just hit trace and just hit negative 5, enter. Let's all get over there at the same place. Now, what I'd like you to do is just I want you to keep tapping right. And look at your numbers over here. What should this start approaching? Look at your x value. It gets closer and closer to -1 and then jumps. It jumps across the line. Now, this isn't doing a very good job of actually getting, but you will see -1.063, and then it jumps to because it's actually up here now. I don't know if you know that. It jumped from down here to up here. See, it's not allowed to be -1. You guys understand that? So as soon as it gets to that, it would go to infinity, right? The calculator says, okay, well, I'm not going to waste your time. This would go to infinity. Let's get where it starts again. And it starts, and then it cruises along. You can see it. You can see, where is it going to get to? It's going to get to 1.5, 1.48, and then goes to 1.7. Actually jumps. Now, that's not new to us. Here's what is new. If you look at the... Okay, now, that's not making sense. Because there's 2.34. What is my horizontal asymptote? It's a half. So we're looking here. Okay, everybody look here at the y, because it's y equals. So you cruise. There it is, 0.4, 0.46. Why is it bigger? Because 0.5 is supposed to be, like, shouldn't it just cruise along? But it actually went through it, and now if you cruise along, it gets bigger, and then what starts to happen? It gets smaller, and you will see it will approach 0.5 in infinity. So, what is the gist of this? What am I trying to get across? See, when you put in the point -1 here, this whole thing doesn't actually exist. When you put a 1 in here, or a 0 in here, well, 0 is a bad example. Well, it would work because of this. But if you put a 0 in here, you still get the answer 1/2. So here is kind of what I need you to know, is that the graph can go through the horizontal asymptote. But will reach the asymptote at infinity. So, vertical asymptotes, the graph will never go through it. Horizontal, it can. And that's very key to know. Now, The other thing that when you do start getting slant asymptotes, and if you look on the board, that when you do have a slant asymptote that maybe goes like this, and if this is my graph, it's going like this. Okay, it may still ask you for the range. Now the range is everything but this stuff in between. Now they're not going to ask you for this asymptote, but they want you to know, well, what would the range be? So to find the range, you're going to have to find, now this is going to be a minimum value, this will be a maximum value. Now that's confusing because you're like, what? Why is the minimum above the maximum? No, minimums are always when it's a concave down. So whenever you're doing a down, you'll always find a minimum, and when you're doing a up, right, you will get a maximum. And then you're going to get your y values, right? And that's going to be your domain or range. So just make sure you know that. I think for 1C, you're going to have to know that. Okay? So we're doing 1 and 2 and 4 to 9.